recording later on if you want to revisit. So source is always at high temperature and sink is at low temperature. So heat transfer will always take place from source to a sink, high temperature to low temperature. That we all know, right? So looking at heat engine now. What is the heat engine? You have done this before, right? So can somebody explain what is the heat engine? Devendra.
Yes, sir. In a heat engine, the engine absorbs. Am I audible?
Yeah, I can hear you.
In a heat engine, the engine absorbs heat from the source, which is at higher temperature, and does the work at lower temperature, which is then rejected to a some part of that heat absorbed is used to do work, and other part is expelled to the atmosphere or rejected at lower temperature.
Okay, good. So essentially heat engine is what converts heat to work, right? Like a power plant. If you've seen a power plant, there's a boiler in which we burn coal or fuel, any fuel, right? That generates the steam. Then the steam from the boiler goes to a turbine. In the turbine, it does work. That means it converts this heat energy into work, which is in the form of electrical energy. Because here you have a what you call turbine and what is it called? Basically, it converts mechanical energy into electrical energy. We get electrical power here, and then whatever is steam is there at a lower pressure and lower temperature goes to the condenser where it is condensed. This is again steam which is condensed. So when we condense, the heat is rejected to energy sink, or which could be a cooling medium. Heat exchanger is a cooling medium which condenses the steam, and then the water goes to the pump. From the pump, again there is energy input to the pump, and then this is pumped to the boiler where it is again vaporized at high pressure. So that is the heat engine, converting essentially this heat energy into this electrical power and rejecting some energy to the atmosphere or to sink, right? So it is represented as this heat source at high temperature goes to the heat engine, you get electrical power and you get heat rejected to the low temperature sink. If you have any doubts, you can always stop me and ask me, right? So in the operation of heat engine, heat is converted to work. Heat is absorbed from the hot body and it is transferred to a cold body. So some heat goes to the cold body, and in the process we get this work done. And efficiency of heat engine is nothing but what is the work output from the power plant divided by how much is the heat input to the power plant. So W upon Q is the efficiency. So heat engines will have their own efficiency. Like if you look at your bike which you use, that's an internal combustion engine. It takes petrol and converts it into mechanical energy, which drives the scooter or bike. Right? In this case also, some heat is lost to the atmosphere because the engine becomes very hot, and the heat is dissipated to the atmosphere as a cooling medium there. So not all the heat is converted to work. So efficiencies will depend on the or conversion will depend on the efficiency of the heat engine. So some heat engines will have efficiency low, or some may have high, depending on the construction of the heat engine. So what we talked about, this scooter or bike, will have typically efficiency of about 25%. So almost 75% of the energy in a petrol liter of petrol is wasted. If it is diesel, almost 40% of the energy is converted to work. And if it is gas turbine power plants, it is almost 60% efficiency. So depending on the type of heat engine, you'll get different efficiencies. Okay, so any questions so far? Okay. So refrigerator, you know refrigerator, right? You have a refrigerator at home. So how does it work? Can somebody tell me how does the refrigerator work? Siddhi?
Uh,
How does the
Sir,
refrigerator
it
work?
takes heat from lower temperature sink and it rejects to a higher temperature reservoir.
Yeah. So what it does is it takes heat from inside the refrigerator, which is a low temperature, and we supply power to the refrigerator because there is always a compressor working in the background, right? So we supply power through electrical energy, and this power or additional work input to the refrigerator pumps the heat from the low temperature inside, which is normally around 4 degrees centigrade inside the refrigerator, or in the freezer, which may be around -10 or -5 degrees centigrade, depending on what is your setting. So it pumps heat from that low temperature to the room outside the refrigerator, which is around at 30 to 35 degrees centigrade. Right? So if you look at this refrigerator, this evaporator is inside the refrigerator. That means the refrigerant is evaporated here. That means it takes the latent heat from inside the refrigerator, evaporates, and then it goes to a compressor. With the compressor, it is compressed. So this refrigerant which is coming from the evaporator is at say 120 kPa and -20 degrees centigrade. It is compressed by using the compressor to 800 kPa and 60 degrees centigrade. It becomes hot. When you compress a gas, it becomes hot. So it goes to 60 degrees centigrade. Then it goes to condenser, which is behind the refrigerator, which is cooled by the ambient air. Air inside the kitchen will cool the what you call refrigerant in the condenser. If you have an old, if you look at an old condenser refrigerator, you'll see coils which are open, and you can see how hot the coils are. But nowadays the coils are covered, but still you can feel the backside of the refrigerator is hot. Right? So it rejects the heat to the surrounding air and cools down the refrigerant from say 800 kPa. Pressure is same, but temperature reduces from 60 degrees centigrade to 30 degrees centigrade. So it cools and condenses the refrigerant. Now this liquid refrigerant, it goes to expansion valve where it is expanded, pressure is reduced from 800 to 120 kPa, and in the process the temperature is reduced. This is called Joule-Thomson effect, which you must have studied, right? So when you expand the gas, it cools down to -25 degrees centigrade, and the cycle is repeated. Right? Schematically, we can look at this way. This is a cold refrigerator space, and we get energy input from the electrical supply to the compressor, which takes the heat from the refrigerator QL and pumps it out to the ambient air, which is QH. So the coefficient of performance is essentially always output upon input. So desired output is how much heat is removed from the refrigerator, which is QL, divided by what is the heat or energy input to the refrigerator, which is WN. So that is the coefficient of performance. And normally coefficient of if the coefficient of performance is higher, that means your refrigerator is more efficient. Any questions on refrigerator? Okay, so if you are good with that, then let us move heat pump. So what is heat pump? Can anybody explain? Dikshita?
Sir, it is same as a refrigerator.
यहाँ
But
बैठिए
the
everybody.
effect
हाँ.
is, the desired effect is to heat the homes or the place.
Is it refrigerator?
It takes heat from a low temperature reservoir and with work done on it, it rejects the heat to a higher temperature reservoir.
In that sense, it is similar to that. But in this case, what you are doing is you are pumping heat from a low temperature to high temperature inside the room. The fridge does the same thing. From inside the fridge, it pumps it outside. But here, what is happening is you have cold air outside the room in the winter, especially in the what you call Western countries, US and Europe, etc. When the temperature goes down in the winter, the temperature outside is very low, say -4 degrees centigrade. So you take the heat, whatever, air from outside and again supply heat, electrical energy, and then pump it inside the room where the temperature is higher at say 20 degrees centigrade. So in this case, the objective is how much is heat is supplied to the room, not QL. In refrigerator was how much heat is removed from the fridge, whereas here we are more looking at how much heat is supplied to keep the room warm. So desired output is QH, whereas input is again QWN. Okay, so this is a representation of the same thing. Outside air is low temperature, heat pump is pumping heat inside the room. So there are two statements of second law, right? Clausius statement and Kelvin-Planck statement. So who can tell me what is Clausius statement and what is Kelvin-Planck statement? Nupur? Nupur, can you hear me? Nupur, can you hear me? No? Okay, who else is there? You're supposed to participate. It's not a one-way communication. Siddhi,
Yes, sir.
what is Clausius statement?
Sir, I don't remember it.
You don't remember it. Okay, who remembers Clausius statement and Kelvin-Planck statement?
Sir, in Clausius, I'm actually confused between the two, but I know for sure that one of
Okay,
those
tell.
says that we cannot transport heat from lower temperature to higher without doing work. And I guess in Kelvin Planck statement, it says we cannot fully convert heat into work without having a low temperature reservoir.
Good. Who is this?
Virat sir.
Viraj. Good. थोड़ा उल्टा बोला but correct है, statement correct है. It's okay.
That
Statements are correct. Both statements are correct. Okay, so Clausius statement is it's impossible to construct a device which operates in a cycle whose sole effect is to transfer heat from a cooler body to hotter body. Right? So if you want to transfer heat from a fridge to the room environment, you need to supply heat. That is Clausius statement. Is that what you said, Viraj?
I guess I said this for Clausius or
Okay.
something ulta. I said.
It's okay, doesn't matter. So essentially, if you want to transfer heat from a low temperature to high temperature, we need to provide some work in order to do that. That's what Clausius statement says. Right? So all real refrigerators require heat or work to get heat to flow from cold area to warm area. Spontaneous flow of heat from a cold area to hot area would constitute a perfect refrigerator, which is forbidden by second law. Second law does not allow you to transfer heat from cold to high temperature without supplying heat, without supplying work. Sorry. Okay. Kelvin-Planck statement: it is impossible for any system to operate to admit new guests who are coming in. It's not automatically working. So I need to keep checking if there are new people waiting in the lobby. Okay, so it's impossible for any system to operate in a thermodynamic cycle and deliver a net amount of energy by work with surroundings while receiving energy by heat transfer from a single thermal reservoir. What does it mean is we have only a source and no sink, you cannot convert this to work. That means 100 kilowatts of heat cannot be converted to 100 kilowatts of work. We need to have another thermal reservoir which acts as a sink to reject the heat. Then only we can convert this energy from the source to work. So this sim is violating the Kelvin-Planck statement. That means it is converting energy from a source to work without rejecting it to the environment. So all real heat engines lose some heat to the environment. There's a hot reservoir, there's a cold reservoir, there's some heat lost to the environment or cold reservoir, then only you can get some work done. And extracting heat QH and using it all to do work would constitute a perfect heat engine forbidden the second law. So you cannot just convert heat directly to work without this cold reservoir. And efficiency is nothing but this output upon this input, which is W upon QH. And by first law, W is nothing but QH minus QC. So it is QH minus QC upon QH. Okay. So any questions so far? Okay, so these two statements are supposed to be equivalent, and yet we can see how they are equivalent. So if you look at this high temperature reservoir, heat engine, and if you add heat engine with 100% efficiency, right? So QH is getting converted from this high temperature source to 100 whatever QH of work. So work, that means we are putting a heat engine of 100% efficiency here to convert entire uh, heat supplied into work. And if you put that into as input to the refrigerator, that means QH is input to the refrigerator or W net. Then in that case, we can pump say QL energy from the refrigerator to high temperature. So it will be like QL will be input, output will be QH plus QL, right? So we can write this as equivalent refrigerator will be like QL is transferred to QL. So this QH is equal to QH, right? So in this case, this is your Kelvin-Planck statement, Clausius statement. This is your Kelvin-Planck statement. That means they are both equivalent statements. So both the statements lead to the same conclusion, and it shows us the direction of transfer of energy. Any questions on what we have done so far? Okay. Okay, so taking it forward, the perpetual motion machine which violates first law. In this case, we have a boiler. There is a resistance heater, वगैरह. Then there is a turbine, condenser, and pump. And there is a heat out from the condenser and work out from the generator. Turbine is connected to generator. So this is violating first law because now you have this work is there's a work output and there's a heat output. There is no head energy input. So it is creating heat, rather creating energy out of nowhere. This is violation of first law. And perpetual motion machine which violates second law, we have Q in here in the boiler and W out here in the turbine, but there is no sink. That means all the energy which is input to the boiler is converted to work. So again, this is a violation of second law. Okay, so Carnot engine. Do you remember Carnot engine? Carnot cycle or Carnot cycle? Anybody remembers Carnot cycle? Devendra?
Reversible engine, cyclic
Reversible.
reversible.
Cycle is reversible. Okay. What else?
So the efficiency of the engine is 100%.
Efficiency of the engine is 100%. Carnot engine efficiency is 100%, is it?
Close to.
No, sir. No, sir. But efficiency of Carnot engine is higher than any other cycle.
Yes,
Yes,
exactly.
maximum
Carnot
and
engine.
real.
Yes, Carnot engine tells us what is the maximum efficiency which can be achieved for a particular heat engine. In
Yes.
in
Yes, sir.
reality, a real heat engine will never achieve the efficiency of Carnot engine. It will always be less than the efficiency of Carnot engine operating between the same temperature of source and sink. Right?
Yes.
So let's see what is Carnot cycle. Okay. So you have a pressure volume diagram here. Right? Let us see. So you have 4 steps in Carnot engine or cycle. reversible isothermal expansion from VA to VB. So this is VA and this is VB. So it's reversible isothermal expansion at the source temperature or high temperature. And this happens where? If you look at heat engine, where does this happen? Yeah. So where does reversible isothermal expansion happen? Sorry, not refrigerator. Yeah. Where does reversible isothermal expansion take place in a heat engine? This side, this. Anybody?
In the boiler.
Huh?
In the boiler.
Boiler.
Boiler. Okay, expansion. Okay, let's complete all the 4 steps, then we'll come back. Okay, then you'll be able to correlate probably better. Let's see all the 4 steps, then we'll go back to that cycle and correlate with that. Okay, so first step which is mentioned here is reversible isothermal expansion from VA to VB at T hot, right? So which is from here to here. That means pressure is reducing and volume is increasing. When is the expansion? Volume is increasing from VA to VB. Volume is increasing, so pressure has to reduce. Ideal gas, right? P is inversely proportional to volume, right? PV is equal to RT. If the pressure reduces, then only volume can increase. So this is heat gained is QH. Work done by gas is minus W1, it says. Let's not worry about that. Let's look at these steps. Then reversible adiabatic expansion VB to VC. So VB to VC is reversible adiabatic expansion. Again, pressure is getting reduced from PB to PC and volume is getting increased from VB to VC. Then third step is reversible isothermal compression from VC to VD at low temperature, right? Where what happens when expansion happens here, the temperature also reduces, okay, in this step. And here what is happening is now pressure is increasing, isothermal compression, right, from VC to VD. Compression means pressure has to increase and volume has to decrease. From VC to VD, it is reversible isothermal compression. So compression takes place at constant temperature, like this expansion takes place at constant temperature. And fourth step is reversible adiabatic compression from VD to VA. Again, compression, so pressure has to increase and the volume has to reduce. And again, this is reversible adiabatic compression. So VD to VA. So these are the 4 steps. Isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. So 2 expansions, 2 compressions. One is reversible isothermal expansion, another one is adiabatic expansion, and reversible isothermal compression and adiabatic compression. Right? So let us correlate with the heating. Okay, so now look at this. What happens in the boiler? what happens in the boiler?
Sir, in the boiler, water is heated and its volume also increases. That is, it expands. It absorbs the heat from the generator turbine.
Sir, isothermal expansion
What happens to the pressure?
reduces.
Pressure reduces in the boiler, is it?
Yes, sir.
How's the pressure reduced in the boiler?
Sir, what liquid phase is getting converted into vapor form. So pressure reduce होगा.
How many people agree with? So who is this?
Murtuza, sir.
So when in the boiler, he says pressure is reduced.
Sir, in the boiler, I think so. The volume of the water increases. That is, it expands due to the temperature increases.
Mm-hmm. Okay.
Because of it, because it absorbs the heat at higher temperature.
Okay. और क्या होता है? ठीक है. पंप में क्या होता है? पंप में क्या होता है? फ्लूइड फ्लो पढ़ा है ना? पंप में क्या होता है? What happens in the pump? अरे फ्लूइड फ्लो पढ़ा कि नहीं पढ़ा है?
Sir,
Sir, it is used for
compression.
transportation
It's used for
from
transportation.
boiler.
What happens? प्रेशर कम होता है, बढ़ता है, क्या होता है?
Increase होता है sir.
हाँ?
Increase होता है, sir.
प्रेशर इंक्रीज, राइट?
Yes.
प्रेशर इंक्रीज होता है, बराबर? And in the pump, there is no heat transfer to or from the pump, right? There is no
Yes.
heat in, there is no heat output. Barabar?
Yes.
So pump is essentially an adiabatic compressor.
Adiabatic. Yes.
Barabar? You agree? Pump is adiabatic compressor. Turbine में क्या होता है?
Expansion होता है sir. Pressure reduce.
Expansion, right? Pressure reduces, volume increases, right? बराबर? टरबाइन में क्या होता है? टरबाइन में भी there is no heat transfer, there is no heat. It is again adiabatic. Right? So pump is adiabatic compressor. Turbine is adiabatic expander or volume increases, right? ठीक है? So ये तो बराबर है. Do you agree with this? Pump and
Yes.
Yes sir.
right, that leaves only two other processes which are isothermal expansion and isothermal compression, right?
Compression.
Barabar?
Sir, but in the diagram, the pressure is found to be decreased, and here in the pump, the pressure increases.
हाँ, तो पंप इज डिक्रीजिंग, राइट? यहाँ पर डिक्रीज हो रहा है, यहाँ पर इंक्रीज, यहाँ पर इंक्रीज हो रहा है, यहाँ पर डिक्रीज हो रहा है. See, one is adiabatic compressor, one is adiabatic expansion, right? तो यहाँ एक्सपांशन हो रहा है, यहाँ adiabatic एक्सपांशन हो रहा है, यहाँ क्योंकि प्रेशर रिड्यूस हो रहा है, राइट? बराबर?
हाँ.
एंड यहाँ पर पंप प्रेशर बढ़ रहा है, तो इट इज adiabatic compressor, राइट?
Okay.
बराबर है?
हाँ.
If you have doubt, ask me now, because you have to correlate that Carnot cycle with this thing. Otherwise, you will not be able to correlate with actual heat engine. So this is adiabatic compressor. This is adiabatic expansion. Whatever. Now what it leaves is isothermal expansion and isothermal compression. Right? This is again isothermal. Condenser is always isothermal. It is converting vapor to liquid. And boiler is always isothermal. It converts liquid to vapor.
Yes.
Whatever. So which is where does expansion take place and where does compression take place?
Sir, compression in condenser.
Compression in condenser बोल रहा है ये?
Sir, volume is decreasing as gaseous phase is converted into liquid phase. Volume is decreasing, so pressure will increase and compression होगा. Since volume is decreasing.
Okay. How many people agree with what Murtaza said? You can chat or you can show hands. होता है क्या hands यहाँ पर?
Sir, pressure will increase in condenser.
Pressure will increase in condenser. Okay. वही बोल रहा है
Sir,
ना Murtaza?
टेम्परेचर के डिक्रीज हो जाने की वजह से वो कंडेंस होता है ना, इसलिए वो
राइट. सो किसी ने पावर प्लांट देखा है क्या? पावर प्लांट देखा है किसी ने? नहीं देखा कभी पावर प्लांट?
देखा सर.
देखा है? कौन है, किसने देखा? पावर प्लांट में क्या होता है? वाटर इज एट 1 atmosphere which is pumped to the boiler, right? So it is at low pressure which is pumped to the boiler. In the boiler, the water is converted to steam. Yes, expansion may take place, but then pressure is increased in the boiler because boiler से जो pressure आता है, steam आता है, that is at 20, 30, 40 atmospheres. Input to the boiler is at 1 atmosphere. So compression takes place in the boiler. The steam which is generated first, it is converted from liquid to vapor, yes, but उसके बाद compression होता है पूरा उसका, और उसका high pressure पे steam मिलता है वहाँ पर, and that is what is driving the turbine. High pressure steam has to go to the turbine to generate power in the turbine, because this is reducing the pressure from here, high pressure to low pressure steam. Heavy steam रहता है, low pressure steam रहता है. That's why it is expansion. And then when it comes to the condenser, again pressure is reduced. Right? So यहाँ पर pressure बढ़ता है, यहाँ pressure बढ़ता है, यहाँ pressure कम होता है, यहाँ pressure कम होता है.
Sir, but if volume increases, pressure should decrease, right?
Okay, bhai, if I take ideal gas, right? Initially it increases. When I convert liquid to vapor, it increases. But when I say increase the pressure of steam from 1 atmosphere to 20 atmosphere, क्या हो जाएगा?
Increase होगा.
Increase होगा pressure. Volume pressure बढ़ा दिया मैंने.
Right.
So I take steam as ideal gas. Yes, steam. Now I'm considering only steam. Don't consider water and steam. Consider only steam. 1 atmosphere में steam है. I am increasing the pressure of steam to 10 atmosphere or 20 atmosphere. Volume क्या हो जाएगा?
Increase.
Volume increase होगा, कम होगा ना?
Volume increase होगा ना?
अरे pressure बढ़ा है मैंने.
हाँ, okay, कम होगा. Right. हाँ.
If I am taking steam at 1 atmosphere and increasing the pressure to 10 atmosphere, 20 or 30 or 40 atmosphere, तो correspondingly volume कम होगा ना?
Right. हाँ.
Volume कम हो गया यानी compression हो गया ना?
हाँ.
Yes, ना?
हाँ.
So it is really compression takes place here in the boiler.
Yes, sir.
Condenser में expansion होता है because यहाँ पर भी expansion हो रहा है, pressure reduce हो रहा है, यहाँ पर भी pressure reduce होता है. Because what we get out of here, you see, this is अभी देखा आपने. Let me show you the pressures. कहाँ गया? हीट इंजन का प्रेशर नहीं है इसमें दिया हुआ, बट जनरली क्या होगा, यहाँ पर प्रेशर रहेगा अराउंड 20, 30, 40 एटमॉस्फेयर्स. यहाँ पर जो टरबाइन से आएगा इट विल बी लाइक 4-5 एटमॉस्फेयर्स, और यहाँ से कंडेंसर जो आएगा इट विल बी एट 1 एटमॉस्फेयर. तो प्रेशर इज रिड्यूसिंग फ्रॉम हियर टू हियर टू हियर, और फिर यहाँ पर आके जो 1 एटमॉस्फेयर से आएगा इसको इंक्रीज करके 2-3 एटमॉस्फेयर हो जाएगा, और देन इट विल गो टू बॉयलर. फ्रॉम हियर इट विल गो फ्रॉम 2-3 एटमॉस्फेयर टू से 30-40 एटमॉस्फेयर. तो यहाँ प्रेशर बढ़ रहा है, यहाँ प्रेशर बढ़ रहा है, यहाँ प्रेशर कम हो रहा है, यहाँ प्रेशर कम हो रहा है. दिस इज एडियाबैटिक, दिस इज एडियाबैटिक, ये आइसोथर्मल, ये आइसोथर्मल. ठीक है. एनी डाउट्स, क्वेश्चन सो फार? क्वेश्चन है तो पूछ सकते हैं मुझे.
सर बॉयलर में आइसोथर्मल एक्सपांशन होगा ना?
आइसोथर्मल कंप्रेशन होता है.
ओके ओके.
कंप्रेशन होता है आइसोथर्मल बिकॉज टेम्परेचर इज कांस्टेंट हियर. इट्स ओनली कंप्रेस बिकॉज वी आर जस्ट इंक्रीजिंग प्रेशर. जितना स्टीम जनरेट होते जाएगा उसको कंप्रेस करते जाएंगे, प्रेशर बढ़ते जाएगा उसका. और किसी को क्वेश्चन है, डाउट है? दीक्षिता, सिद्धि, एनी क्वेश्चन? नुपुर?
No, sir.
समझ में आ रहा है कि नहीं आ रहा है? रिवीजन है
Yes.
ये, not related to CET2, but I thought because फर्स्ट और सेकंड और इम्पोर्टेंट, थोड़ा रिवाइज करना चाहिए. आपका एग्जाम भी नहीं हुआ ना,
Yes, sir.
दैट्स व्हाई आई थॉट मे बी थोड़ा रिवीजन करना चाहिए इसका. Okay, so let's go get back to Carnot cycle. Okay, now you have expansion, reversible आइसोथर्मल expansion. ये क्या हो जाएगा? What is this thing now? A to B.
Condense. Sir, it will be condenser, no?
कंडेंसर होना चाहिए. यहाँ पर कैसे दिया है इसने? आइसोथर्मल एक्सपांशन, आइसोथर्मल कंप्रेसर, आइसोथर्मल.
सर आवाज क्रैश हो रहा है सर.
आवाज क्रैक हो रहा है क्या? या इंटरनेट का प्रॉब्लम होता ही है दोपहर के टाइम पे. कल भी ऐसे हो रहा था मेरा. सवेरे बराबर आता है आवाज, दोपहर को क्रैक होता है. इंटरनेट स्पीड थक जाता है. इंटरनेट भी थक जाता है दोपहर को. थोड़ा इसमें सोचना पड़ेगा मेरे को. व्हाई इट्स सेइंग लाइक दैट?
सर, ये अगर हम रेफ्रिजरेटर को लगाए तो कार्नोट इंजन.
है ना, लेट अस सी. ये थोड़ा इसने जो दिया है, मैं टेकन इट फ्रॉम समवेयर, ये थोड़ा गलत लग रहा है. ये जो डाला है QH और W, ये थोड़ा गलत लग रहा है मेरे को. बिकॉज इफ यू लुक एट दिस डायग्राम ऑल्सो, क्या होता है नॉर्मली बिटवीन दिस PV डायग्राम के अंदर में क्या होता है, एरिया अंडर द कर्व इज व्हाट यू कॉल वर्क डन और हीट एडेड, राइट? सो A B के बीच का जो एरिया है, दैट इज हीट इनपुट. दिस हीट इनपुट. I cannot show the arrow. So this is normally the heat input, right? Or so B में क्या है? ठीक है, I think I'll have to come back tomorrow and explain because this is not correlating. This diagram is not correlating with this table, or at least I'm not. Okay, इसका कल रिवाइज करेंगे हम. Just this part कार्नो साइकिल कल करेंगे हम. ठीक है, इसके अलावा इसके पहले का समझा गया. कार्नो साइकिल विल रिपीट. तो सेकंड लॉट ठीक है क्या? किसी को डाउट है क्या उसके ऊपर? कार्नो साइकिल विल डू टुमारो और नेक्स्ट टाइम. Any questions on first law, second law? Yeah, the statements of second law also.
Sir.
Okay. So I'll stop the recording, and you can see the recording